the first thing you always want to do with these types of problems is take the information that you're given in the problem and make sure that that information is represented on your table. Okay, that's the very first thing you should do. Now we can use our change in y, change in x to figure out what's in all these empty boxes here. But real quick, which of these two variables here, time and distance, which one is going to be x? Time, that's right. Time is always going to be our x, so distance is then going to be our y. So if we look at our x row here, we go from 4 to 8, yes? That would be a change in what? Plus 4, exactly. Plus 4. Down here, the next one, we're jumping over. If we do the same exact thing, it's at a steady rate, right? So we can do plus 4 and we'll get 12. What's going to go in this next box? 16, exactly. Mr. Church, where did you find the plus 4? From the two numbers that were given to us, right? Because we know it's a steady rate, we're going to have the same change from point to point to point. You're always going to be given two numbers right next to each other so you can figure out what the change is going to be. But we see that throughout the x row, we have plus 4, plus 4, plus 4, plus 4. Down here with this 3 that we found, well, we don't know what our change in y is just yet, so we can't fill in this next box. But look at that. We got two numbers right next to each other. And what's that change from 9 to 12? Plus 3, right? So if we're adding 3 each time we move our y-coordinate over, what would our next box be? 15, exactly. What would have to come before 9? That's right, Leslie. 6 has got to come before 9 so that plus 3 makes that statement true. And from 3 to 6, we see that we also have plus 3, right? Great job. So we got to find our slope. That's just the change in y over the change in x. So what's our slope going to be here? What over what?
3 over 4.
3 over 4.
Is it 3 over 4 or 4 over 3?
3 over 4.
3 over 4. Y over x.
After the first.
Okay, so our slope is 3 over 4. Now let's go ahead and graph this relationship. Okay, as I look out at your guys' paper, it looks like most of you guys graphed this. So let's go ahead and see what's going to happen. We're going to plot these points. 4, 3. We go over 2, 4, 6, 8. I'm just going to write these in. So we go over to 4 on the x-axis, 3 on the y-axis, 8 on the x-axis, and 6 on the y-axis. Then we got 12, 9. $16, 12. And we got 20, 15, right about there. And if you did everything right, you should see that, hey, those dots form a line, right? Just like that. Real quick, what kind of relationship do we have here just based on this graph? Proportional, that's right. How do you know it's proportional? Just by looking at it. Jordan?
It goes to the origin and it's straight.
That's right. It's a straight line that goes through the origin. This one, just so we know, is proportional. Okay, not super relevant to what we're doing, but it's just a good review before our final next week.
Final.
Yeah.
Finals is next week, yeah.
Next week.
It's week 8. Next week is week 9.
It's week 8.
Yeah.
Week 8?
So we're going to take our final next Thursday, right? And then when you come back, you'll have your different classes, except for this class.
I'm
Yeah.
so glad to be in the history.
All right, sorry for the distraction. Let's come back together. We're almost done with this one. So we found that our slope was 3/4, but just like we talked about in the warm-up, right? We need units on our answer. What are the units going to be for 3/4?
Miles per minute.
Miles per minute. Absolutely right.
Hooray.
So we've got our units. Let's just say real quick that the geese fly at a unit rate of 3/4 of a mile every 1 minute, right? The unit rate, our second quantity has got to be 1. So 3/4 of a mile would be like 3 laps around the track, right?
In a minute?
In a minute. That's how fast these geese are flying. They're whipping 3 laps around the track in just 1 minute.
It takes me like 8 minutes. No, like 7 minutes. It takes me a minute to get like to the first turn.
Yeah, so if we look back at the table too, we can get all kinds of information from this, right? It takes these geese only 8 minutes to fly 6 miles. That's wild. Most of you, or some of you, might run an 8-minute mile. These geese are flying 6 times faster than that. Just interesting information to have. Okay, so number 8. Yes.
I did them all in like order, so I didn't like. They might be like different weeks on different papers, but I did do like all of the stuff that we wrote.
Okay, can we talk about this in a couple minutes? Because I'm trying to go over this one.
Alright, my bad.
All right, number 8, real quick. This one is just circle the correct vocabulary term. So a unit rate is a rate in which is it first or second quantity in the comparison is 1 unit. Go ahead and hold up a 1 if you think it's the first quantity. Hold up a 2 on your fingers if it's the second quantity.
Wait, what makes the table faster?
What's that? So a unit rate is a rate in which the first or second quantity is 1 unit. Show me a 1 for the first quantity, 2 for the second quantity. Good. Okay. Thank you to those of you who actually did that. The second quantity in our comparison needs to be 1. All right, let's go on to number 9. Any questions about this one up here with the geese? Fairly straightforward, right? All right. So number 9, now we're doing something a little bit different. So we got 2 different machines that we're comparing. We're comparing machine 1 and machine 2. So this table and this graph don't represent the same data. It's 2 completely separate pieces of data, right? And this table and this graph represent how fast these machines are bottling milk. So we have to determine the slope and the unit rate of each machine. Those are the same thing. We just have to find M. And then we're going to determine which one is working faster. So this one's a little bit different, but we're just doing the same thing twice, and then we're going to compare. So with a table, finding our slope is nice and easy. We look for our change in Y and our change in X, right? What's our change in X from point to point? Plus 1. And what about here, from 0.6 to 1.2, what are we adding?
Plus 0.6.
Plus 0.6. Now Now, I know decimals can be scary, but it's all right. We're going to do the exact same thing we've been doing.
I'm so scared.
So for this first machine, our slope is equal to the change in y over
Over the change next.
the change in x.
Yeah.
0.6 over 1. What does that simplify to?
0.6
0.6, right?
gallons per hour.
And that's right. The units that we need on 0.6 are going to be gallons, not per hour, per second.
Oh, how did I get that?
0.6 gallons every single second. Anyone notice anything about that graph? Or not that graph, sorry. Anyone notice anything about this table here?
It's
Specifically the first point on the table?
It's not equal to 1.
It's not equal to 1?
Alice, I think that's.
So take a look real quick.
Then 1.
This fraction that we set up, right? We used our change in y and our change in x. But it looks like we could have just used our first point, right? You guys see what I'm saying? We could have just done y over x, 0.6 over 1, and got the exact same answer, right? So what kind of relationship do we know that we have here with this machine?
Proportional.
Proportional, exactly. Our formula for k is just k equals y over x, right? And as I said yesterday, it's the same thing as finding slope, just the context is a little bit different. So when we have a proportional relationship, we're looking for when time is equal to 1, right? When we're trying to find the unit rate. Time needs to equal 1. Here on our table, look, we've got the gallon amount when time is equal to 1. So we could have just done k equals y over x. Either way, you get the same answer, so it doesn't matter which one you do. Let's take a look at this second one. Anyone see a point on this graph that stands out?
Yes.
I know it's kind of hard to see. Where do you see a point, Noah?
8,6.
8,6. Boom, right there. Absolutely right. 8,6. Anyone see another point that we can use on this graph, Azalea? 16,12. Yeah, that one looks good. 16,12. Awesome. Is there another point maybe we could use?
No.
And no one else sees another point? What about this point?
Wait.
What about the origin? Doesn't it go through that point? It sure looks like it does.
But it's 0, 0.
That's right, and that's going to make our slope formula a lot easier, don't you think? If we can just subtract 0 from a number, it's a lot easier than us subtracting 6 from a number. So again, it doesn't matter which 2 points you use, but we're going to use the slope formula. y2 minus y1 over x2 minus x1. And I'm going to go ahead and take these 2 points here that you guys identified. So we're going to have on top 12 minus 6, and we're going to have 16 minus 8. That gives us what on the top? Sorry. 12 minus 6 gives us 6, and then 16 minus 8 gives us 8. Can we simplify 6 over 8 at all?
Yeah, no.
Yeah.
Yeah, we can. What's that simplify to?
3, 4.
3
Over 4.
over 4. What's our units here again?
Gallons per second.
Gallons per second. So we have the same units here, right? Because we're trying to compare these two machines. So let's go ahead and write here in A, if you haven't already, for machine 1. Okay, our slope is equal to 0.6 gallons per second. In machine 2, our slope is equal to Now here's the thing. We've got 3/4 gallons per second. It's going to be kind of hard for us to compare a fraction with a decimal. So Noah, what can we do?
Turn the fraction into a decimal.
Perfect. And Azalea, what is 3/4 as a decimal going to be? That's right. 3/4 is 0.75 gallons per second. Everyone with me so far on how we got to that point?
Yeah.
Yep.
So we found slope from a table. We found slope from a graph. And then honestly, we could have done rise over run here too
I did.
and gotten the same answer. That's what Noah did. Yeah, you could have done rise over run with the graph. I just decided to do the slope formula. But as you can see, all of those methods work. So now we have to answer number B. Which machine is working faster? Is machine 1 working faster? Go and hold up a 1 on your fingers if you think 1 is working faster. Hold up a 2 if you think machine 2 is working faster. What do you think? Just based on these rates that we found. Good. I see all number 2s up. That's right. Machine 2 is faster. And we can even say it's faster by 0.15 gallons per second. Right? Machine 2 is able to bottle 0.15 gallons more every single second, which doesn't sound like a lot, but if you've got a bottling machine that runs all day long, those numbers add up, and you're saving a lot of time just with that 0.15. All right?